Good day guys, welcome to the TheKnowHow channel. So today we're going to touch also a very sensitive in this industry standard that will work in the solar industry. People believe there's multiple stories going around. One says pre-charge from the AC side, one says pre-charge from the DC side. Let me explain to you plain, basic, simple. This is not a grid tie inverter, not a high frequency inverter. This is a transformer based battery-based inverter. So by basic meaning battery-based inverter means it must be start from the battery side. Yes, you can start up from the AC side, but I believe personally it's not good practice. Okay. Secondly, guys damage batteries by just switch on the battery and close this fuse. Okay, this is your pull fuse. There's multiple names for it. Fuse disconnector, battery disconnect, in case of emergency disconnect. We work in a quite interesting thing. My practice out of experience is to pre-charge from your battery bank your inverter bank. Okay, so guys, this installation don't have it on because this is for training purposes, not for. So most guys install pull fuses at each inverter. That is correct. I don't blame them. I believe it is also correct practice because you can isolate the inverter if you want to work on it. But there's one problem. If you close it afterwards, you actually damage your fuse holder. This fuse holder, if you read correctly, it's not meant to disconnect and connect under load. It's just a disconnect of an isolating point. It's not to disconnect or connect under load. So please guys, you will arc this points away or damage. I always said with that, to damage the points inside is quite bad. So out of experience, I'm trying to help people. Me and Ian have tried to develop a quite cheap and easy product to not damage inverters, not damage fuses. We call it a DC pre-charger. So basically, it comes with a set of 2 crocodile points, like this and like this. So you can connect it anywhere around. There's no correct, as long as it's positive and positive and negative. We have just tried to explain to people, always connected your positive, your negative side and your positive side. You will see there's no voltage on that side because all of these products drain each other. Like your most problem with Victron system, your servo, your GX device drains because as soon as you give this power, this start up at 9 volts and it stops at 96 volts. So as soon as you get any voltage, it will start up. Okay. So you will see my practice is on my battery's bus bar or on my bus bar in front of my fuse holder. I won't close my fuse holder. You'll see it's still open. I will switch on my battery. So let MD go through his procedure. You can hear the contactor is closed. It means the battery is on. You will see here it's voltage. There's no voltage on top. The moment I press this button, the voltage starts going to the top. You'll see it goes up immediately as soon as I bleed it through. You will see it will jump up quite fast. You will see. Now the color control is pulling power, everything is pulling power. So I always say to guys, as soon as the voltage goes up and goes through, you can see here, if I close this thing, there's not an arc from a sword on that battery terminals. You disconnect it, and there's no problems. So guys, this is the easy way of charging up your batteries. No problem. It's on our online store. If you want to see where to buy it, if you want to know why, follow our page. We will show you where to buy it. But guys, please, this is the easiest way to protect your batteries. Take that. Guys, we said on multiple occasions where guys have a 5 kilowatt inverter with a 5 kilowatt battery. This is way out of ratio. I know that because this is just for training purposes. This is 9 kVA, 9 kVA. So if you go onto the website, you will see you need at least, because this is 18, you need 36 kilowatt of battery to run this. This is a 7 kilowatt battery. Yes, we don't pull any loads, it's just switch on. There's no loads connected to this inverter. inverters, but this is a small battery that easily starts this up. Okay, so I'll show you now. I'll pull this fuse under load. I know it's not correct. We'll see. This is the inverters keeping the batteries alive. There it goes dead. Okay, so I tried to explain to you guys how it works. So I'll switch on my MPPT on my MPPT side. I want to see quickly if I can show you this on video. It can happen or not happen. I'm going to close this fuse under load with all of this production. The chance that this battery will open up is very good because it will go under load. But we will see if it happens. If it not happen, good for solar MD. Okay. So if you close this MPPT, you can actually hear it. I will try to keep my mic close as possible to this. How it arc. You can actually hear the battery has opened up. The battery is in error. It opened up its BMS. There's no voltage. You'll see nothing comes on. And then it will go on now. It will try to pre-up again the battery. So guys, make sure you'll see there the battery closed now. And now it's start only up. It's very bad for your batteries to be charged up or switch on under load, because this is still, I still say it's a bulletproof BMS because I use a solid state solenoid at the back to close it. The guys that use a paste BMS is only MOSFETs. And normally what happens is that MOSFET, and that's how I test it. You guys come up and down with me. If the battery been over discharged and you switch off your paste BMS, you will still have voltage coming through your BMS. It means that the MOSFET internally has been arc closed. So it happens, that is an arc that happens, electronically cannot be open again. So please guys, pre-charge your batteries. You can use an incandescent bulb, you can use a resistor, whatever, but this is the correct way of doing it. I promise you, you will have no problems on Victron's side or on the battery side. Thank you.